Okay, in our first problem here, we just have to find the sine of angle A here. So if we look at the sine of angle A, okay, let's remember our sine ratio here. So we have our little mnemonic to help us out. Okay, so the sine is the opposite over the hypotenuse. Now we need to be sure that we're going from the right angle. So notice it says angle A, it doesn't say angle C. So from angle A, the sine is the opposite over the hypotenuse. So that would just be 12 over 13 there. Okay, on the next one, it's a very similar question. Now the only thing on this question is they don't label the triangle for you. Instead, they tell you that in this triangle that the cosine of angle L right there is 7 over 16. So I need to use that information to find the sine of angle N to answer the question. Now, so if the cosine is 7 over 16, recall cosine is adjacent over a hypotenuse. Now, we're from angle L, not angle N, okay? So from angle L, the cosine is adjacent over hypotenuse. Therefore, that leg would be 17, and then the hypotenuse would be 16. Now, let's find the sine of angle N now. Now, notice for the sine of angle N, here's angle N. Now, if we need to, we can use the Pythagorean theorem to find that value, but I don't think we need to. So the sine is opposite over hypotenuse, so that would also be 7 over 16. Okay, now we actually have a problem to solve on this one instead of just finding a trig ratio here. I need my calculator. I'm probably going to mention this to you guys in class here, but when you use your calculator here on the ACT, actually don't really need a calculator for this question, your calculator needs to be in degree mode. Now, the default for a scientific calculator is degree mode, but for a graphing calculator, it's radians. So you need to go to mode and be sure that you have your calculator in degree mode. Now, let's look at our problem here. So it says from the lookout point on a cliff, the angle of depression to a boat in the water is 14 degrees. And the distance from the boat to the shore of the cliff is 2 kilometers. How far is the lookout tower above the water surface? And that's kind of a poor picture here. So I'm going to just redraw this just into a basic triangle. So I'm going to write triangle. I'm going to know I'm not going to use trig here because, let's face it, let's just look at the answers on that. Now, so we got this, the distance to the boat there is 2 kilometers. And it says that the angle of depression on the water is 14 degrees. Now, remember here that the angle of depression is this angle formed when she looks downward. I'm assuming that's a she because she's got a dress on. Now, so this angle is 14 degrees. Now, recall that the angle of depression and the angle of elevation are congruent. So this angle would also be 14 degrees. And that's the angle that's going to help me figure out the question here. So again, we're looking for how far is the lookout above the water surface. So basically what we're doing is we're looking for this height right here. So now we can definitely set up some trig to find this. Notice I couldn't use Pythagorean theorem because I only have two sides of the triangle. So for my angle, I'm going to notice that x is opposite and that 2 is adjacent. So opposite and adjacent would be the tangent function. So we find the tangent of our angle. So tangent of 14 is opposite over adjacent, so we get x over 2. Now, we can solve this by cross multiplying. So 1 times x is x, and then we get 2 times tangent of 14. Now, normally in a math class, what we would do is we would just type this in, and this would be our answer. However, on the ACT, you're expected to be able to answer the questions without having a calculator. So in this case, they leave the answer in that form, 2 tangent of 14 degrees. And now this one is just a little ratio question. It's just a little bit more challenging than those first two. It says, which of the following changes must be made to df right here? So we're going to change df somehow, so that the sine of x is equal to the sine of y. So here's the x, and here's the y. So let's find the sine of x and the sine of y now. So the sine of x, sine is opposite over hypotenuse, so we get 8/10, and then the sine of y would be 16 over 18. So again, the question is asking, what do I have to do to df to make it the same as this one? Okay, so notice if we reduce them, that reduces to 4/5, and then this one would reduce to 8/9. So they are not the same. So there again, we're trying to change df to see what will make it. So what I'm going to do is just look through each of these. So it says increase its length by 3. Now if I did that, I would get 19 over 18. Now 19 over 18 would not reduce to or 4/5 or 8/10. So it's not that one. Now let's increase it by 2. So if I increased it by 2, I'm doing the wrong one. I'm sorry. Let's back up. We're supposed to be doing df. So we're this one we're increasing. Okay. So we try this again. So what about increasing it by 3? So is 16 over 21 the same as 8/10? No, it is not. Okay, so it's not A. All right, now let's try B. So B, we're going to increase the length by 2. So here we would get 16. If I increase that by 2, that would be 20. Now 16 over 20 would reduce to 4/5, and so does 8/10 reduces to 4/5. So that would be B there. So that was a ratio question. Normally the ratio questions are fairly simple, but this one's a little challenging. Again, the ACT is always going to, most of the time, not always, but most of the time is going to take you to another level than you would normally get in a normal test. Okay, now the next one says all the sides of the right triangle are in the same units of length. What is the sine of A divided by the cosine of B? Okay, so let's look. We got, here's the A, and then here's the B. Okay, so let's find the sine of A, and we'll take it, and we'll divide it by the cosine of B. All right, so the sine of A, sine is opposite over hypotenuse, so that's A over C. And then the cosine of B, cosine is adjacent over hypotenuse, so that's also A over C. So if I have A over C, it's the same thing. Something over itself is just 1. Okay, the next question says an angle in a right triangle has measure alpha. Okay, so by the way, that's just the Greek letter alpha. Sometimes I refer to him as fishy. So if sine fishy equals 24 over 25 and tangent of fishy equals 24 over 7, then what's the cosine of fishy? So the key thing to do in this is just to draw us a right triangle. So let's draw us a right triangle, and let's put us an alpha angle in here. Okay, now let's use our ratios. We're going to fill in the triangle by using the ratios. So we're kind of going backwards. And then we're going to find the cosine of alpha. Now they tell me that the sine of alpha is 24 over 25. Now remember, sine is opposite over hypotenuse. So this will be opposite, and this is the hypotenuse. Now the tangent is opposite over adjacent. So from alpha right here, opposite is 24. We've already said that. And then the adjacent side there is 7. Now that I've got my triangle filled in, we can state what the cosine of alpha is. So cosine, remember, is adjacent over hypotenuse. So adjacent over hypotenuse here, that's just 7 over 25. Now the next one, we've got that theta here. That's just the Greek letter theta. And so, by the way, Greek letters are usually used to represent variables in trig. So we have theta is 36 degrees. And of course, we're given the hypotenuse of the triangle. Now we're trying to find this value. So you can kind of look at the answers and tell that we definitely want to use some trigonometry here. So right triangle trig from this angle, this is the adjacent side, and this is the hypotenuse. So adjacent and hypotenuse means that we would use cosine. So we'll say cosine of the angle equals adjacent over hypotenuse. And then to solve this, we could just cross multiply. 1 times x is x, and 20 times the cosine of 36. And normally we would type that in a calculator in a normal class, but you're expected to do the ACT without a calculator. If you don't have one, you still should be able to do it. So all I have is just these two multiplied. It's not written the same way, but I'm multiplying them right there. The cosine of 36 times 20. Okay, now this is a really similar question here. So we have a camper at site C sends a distress signal. The signal is received by both Ranger Station A and Ranger Station B, as shown below. Ranger Station A is 6 miles, so you see the 6. Directly west of Ranger Station B. Ranger Station A is directly south of Site C. The entire region is flat and level. On a map, the angle formed the Ranger Station B by drawing a straight line, and we can see that that's 57 degrees. I'm going to skip to the last sentence. About how many miles away from Site C is the closer of the two Ranger Stations? So we're trying to figure out which would be the shorter distance. Well, it's not this one, because that's the hypotenuse. The hypotenuse is the longer distance. So this is the distance that we would look for. So now, let's set us up. Obviously, look at the answers. It's trig. Okay, we have sine, cosine, and tangent. Now, it's just like the last one, really. So we have this angle, and x is opposite, and 6 is adjacent. Opposite and adjacent is tangent. So we would get tangent of 57 degrees equals opposite over adjacent, and then we just cross multiply here. Now, we're just going to get x equals 6 times the tangent of 57. Again, I don't have to throw it in the calculator. I can see my answers given in terms of tangent right there. Okay, on the next one, we got a missing angle here. So I'm not really going to read through it. Basically what I'm doing is I'm just trying to figure out what this angle is. Now, the problem is that angle is not in my triangle. So what it is that angle is the angle of depression. Now recall that the angle of depression and the angle of elevation are congruent. So even though this is a different angle down here, it'll have the same measure. So if I look at that angle and I see that this is the opposite and that's the adjacent side, that means we would use tangent. So we get tangent of the angle theta equals opposite over adjacent. So it's 120 over 500. Okay, on the next one, we just have to figure out, notice I really don't have to read the question. I can tell exactly what it's asking. I'm going to call the hypotenuse there that's looking for x. Now notice on this problem that they give you some information. Now, if you have a scientific or graphing calculator, you don't need that information. You can type that in. Now, let's look, and from this angle, we'll see that 2 is adjacent, and the missing side x is the hypotenuse. So adjacent and hypotenuse there would be cosine. So we'll take the cosine of the angle. Cosine, again, is equal to adjacent over hypotenuse. So this would be 2 over x. Okay, now we're going to do just like we did on the other ones. We're going to cross multiply, but this one's going to work out differently this time. We'll get x times the cosine of 53 degrees equals 2. And to solve for x here, I would divide by the cosine of 53. Now, a lot of test questions at this point, the answer would just be this. It would be 2 divided by the cosine of 53. But since the problem tells you what the cosine of 53 is, they expect you to divide that. Now, realistically, what we just do with this, if we have a scientific or a graphing calculator, again, it has to be in degree mode, is we just type this in, 2 divided by cosine of 53. There we go. We get 3.3 there. And you can see that's C. Okay. All right. So let's take a look at this one. All right. Now, on most of these questions, y'all, we got to get used to the fact that, you should be careful about answering the questions, but sometimes, and maybe this is me because I like to teach math, but I can look at the picture and tell what to do. I don't have to read it. All I need to do is figure out what leg of the triangle they want me to find. Okay? So let's read the last sentence. How many feet above the ground is the kite when the string is taut? That means pulled tight. So what are we looking for there on that triangle? All right, which leg? The one going up and down, right? The height. Okay? So here we go. So I'm going to call that X. Okay. Now, so by this information, or by the fact that, sometimes that's a similar one, or, you see this in the answers.
Hey, what do you think?
This is just trig, right?
Yeah.
Okay, that's just trig. Okay. Now, let's look. Let's find X. All right, so from 40 degrees, okay, let's identify the two sides, because what we got to do is figure out which trig ratio to use. Okay, so X is opposite, and 130 is the hypotenuse. So opposite hypotenuse is sine. Okay, so I'm going to do the sine of 40. So you say the sine of the cosine of the tangent of the angle equals the ratio. The ratio is opposite over hypotenuse, so that would be X over 130. Okay. Now all we have to do is solve this. So we can, on most of these, you can just cross multiply. You put this over 1, you get 1 times X is X, and then this one would say 130 times the sine of 40 degrees. Okay. Now, a person that wouldn't have a calculator would have to calculate 130 times this. That makes sense? That's why they put that. It's for a person who would not have a calculator. Now, we don't have to do that. We can just type that in our calculator here. Okay, so let's pull up a calculator. Can I get it? All right. So you just type in, all right, 130 times sine of 40 degrees. All right, close that parenthesis. Okay, so 83.5. Now, which one's closest here? 80. Now, why do you think they're a little bit off? Because, right, they're only using 3 decimal places. We're using 99 decimal places. We're a little bit more accurate than they are. Okay? All right, so that's one thing about it. Those questions, you'll have to get the closest answer every once in a while. All right, let me see what this last question is. Okay, let's look at this one. All right, from an observer on the ground, the angle of elevation to a hot air balloon is 21 degrees. Now, let's take a side note here. We probably need to review this. Okay, so angles of elevation and depression. Let me pause. All right. So here we go. They don't really draw you a good picture here, so I may redraw this. It says from an observer on the ground, the angle of elevation to a hot air balloon is 21 degrees. Okay. So we've got. We'll draw the ground. Here's my balloon. Okay. And I'm just going to make me a right triangle with it here. All right. Now, hush, stop talking. It said the angle of elevation was 21 degrees. Okay? The distance from the observer to a point on the ground directly underneath the balloon is 1,500 meters. So where's my 1,500 meters going? Yeah, the bottom leg. Okay, this is 1,500 meters. Now, how many meters high is the balloon? Now, how will we measure the height of the balloon? By the hypotenuse of the leg. The leg. Okay. Now think about, how do we measure heights? If I was measuring the height of the ceiling, I would measure straight up to it, right? I wouldn't do it at an angle. I'd go straight up. Now, let's see which function are we going to use. Now, so from 21 degrees, I have opposite and adjacent. So that would be tangent, right? This is opposite. That's adjacent. Okay? So I'm going to use tangent. All right. So now opposite over adjacent. It's going to be x over 1,500. Now I can just cross multiply. So 1 times x is x. And then 1,500 times the tangent of 21 degrees. Now, take a look at this one. Did the problem tell me approximately how much the tangent of 21 degrees was? No. So when they don't tell you that, do I need to type this in the calculator right here? No, it's in the answer. So a lot of times, because again, you could do the ACT without a calculator, you don't have to push it in here. You just pick the answer. So that's this one.